LeetCode 1155, number of dice rows with target sum. So we are given n dice, and each die has k faces numbered from 1 to k. And we are also given a target. Return the numbers of possible ways to roll the dice so the sum of the face-up numbers equals target. Since the answer may be too large, returns module 10 to the power of 9 plus 7. We first declare a constant variable which is the module. Here is 10 to the powers of 9 k, and we need to remind ourselves of the range of integer is from -2 to the around -2 to -2 this -2 times 10 to the power of 9 to positive 2 times 10 to the power of 9. So in the addition, we have to take module in our in each of our operation, or we will get an overflow error during the runtime. So we click the related topics. We can solve this problem by using dynamic programming. So by using dynamic programming, we first define the tabular form or the table. Here we define the table named after way, and it is a two-dimensional table. For each entry way indexed by I and j, way I, j means the number of ways to roll I dice with an overall sum of j. So we declare here of two-dimensional, or you can just use an array. That will be fine. And since so vector of vector, we call it way. It is, and each row is a vector of size, let's see, of size k plus 1. Okay. So the way table is of size, the shape of it, if we use the Python phrase, it is a n plus 1 by k plus 1 shape. It has m plus 1 rows and k plus 1 columns, and each entry has the meaning defined here. The second step, we are going to find out the recurrence relation between entries. We take an example for a general die having 6 faces. For example, if we want to find out what's the possible ways of generating an overall sum of 7 using 3 dice, then we can concede the least problem in the following way. If the face up number of the third die is 1, then we must have, in order to have an overall sum of 7, the sum of the first 2 dice must be 6. So we only need to consider the last throw, which is in this case the third throw, the third dice is ranking from 1 to 6. All right. Then we can conclude in this specific case, the number of generating sum of 7 using 3 dice is the summation over using 2 dice and having the specific sum of 6 until 2. Why, you may say, why there 1 is not considered? Because 2 dice cannot generate a sum of 1. Or you can think in the opposite way, is that this corresponds to the third dice having a third die having a face up number of 1, and similarly this corresponds to the third die having a number of 2. All right. So in general, the way of n dice with a summation sum underline equals to the number of ways using n minus 1 die and iterate through all the possible face of the last die. The number of face up in the last die. All right. And third, we need to consider the boundary condition. Here we initialize the vector. It's by default the 0 should be 0, but there's one case where the value is not 0. It is the number of ways to form a sum of 0 using 0 die. This will be 1. Okay. Then we can implement the recurrence relation here for number of dice starting from 1 all the way to the maximum number of dice we can have, which is n dice. Okay, so for each number, then we iterate through all the possible sum here. The possible sum starts from number of die, because each die has to have at least one point, so the starting point is n dice. All the way till the target sum, and we increase our sum here. Then we can consider the face, the number of the face up in the last die. Okay, so face starting from 1 all the way to face smaller than k. And face plus plus. So in a general dice, in a general die, k equals to 6. What are we going to do is to update the way using our recurrence relation. So we copy the recurrence relation and paste directly into our code here. So using sum, and then this is sum minus face. Be careful here. There may be case when face becomes larger than sum. Then one way is to using a minimum here to take it over the sum and k, and it should suffice to resolve the index out of bounds issue here. So we need to add, we can use the plus equal sign here, but it is potentially erroneous because it may cause to an overflow in this entry. So we can here to take this one out, and first we do the addition and take the module over the module given to make sure it resides within the integer range in C++. Right. Then after we return the answer with after filling out these tables, this table here. Not dp. So we can try to run it and constant expression. Constant expression XPR. Okay. Oh, integer, right? Seems like we have an overflow here. Alright, this must need to heap buffer overflow. Okay. M plus 1, K plus 1, and target. No, here is target plus 1, right? Okay.